this first one, if you notice in this problem, they give you the fact that the gases are at STP. If gases are at STP, and technically you can use 22.4 liters is equal to 1 mole. So it's like a typical stoichiometry problem. That's my given. I put 4 liters of CO2 there. 22.4 is equal to 1 mole. The coefficient of CO2 is 1. Coefficient of O2, which I'm comparing to, is 3. And then I add 1 mole is equal to 22.4. Technically, if you think about it, you don't even have to include these because they cancel. So to do gas stoichiometry at STP, it's just basically the given and the mole ratio 1 to 3. 1 mole of CO2 equals 3 moles of oxygen. So all you're really doing mathematically is multiplying 4 times 3. Next question. Which of the following oxides is a gas? Well, one thing we know is that all ionic compounds at room temperature are solids. So anything that's ionic I can automatically cross off. Metal, nonmetal, gone. Metal, nonmetal, gone. Metal, nonmetal, gone. So first cross out the ionic compounds, because ionic compounds are always solid at room temperature. The other thing is you should recognize SiO2 as quartz. It's one of the 2 common network covalent compounds that you're supposed to memorize. So that means this is a nonmetal on nonmetal, which means this would be a gas at room temperature. This is a typical titration curve. They ask you, 34 was the one where optimum buffer action occurs. Remember, optimum buffer action occurs halfway to equivalence. This is the maximum buffering region right here. So maximum buffering occurs in the zone right there on a titration curve. So the correct answer is A, point V. Next one. They tell you the word solution. Remember when we talked about solutions, solutions are affected by number of particles. Non-volatile solute in a pure solvent, you're comparing the pure solvent to the solution. So they're telling you with no particles versus the solution. What's the solution going to have? The solution has a higher boiling point. And so if you look at 35, the correct answer is A, a higher boiling point. So it goes back to knowing your chart on the exam. Higher boiling point, higher electrical conductivity, lower freezing point, lower vapor pressure for a solution because the greater the number of particles. The solvent has 0 particles in it before you dissolve something in there. So a solution will always have higher boiling point, higher electrical conductivity, lower freezing point, lower vapor pressure. Here's an example of Lachette. If you look, they're talking about CO2, CO3 2-, which is here, and HCO, which is there. They want to know the ratio can be increased. The way you increase the ratio is the products get larger, reactants get smaller. That's going to happen if you shift the reaction to the right. If you notice, heat is negative, which means heat goes over here. So according to Lachette, we're trying to figure out what causes something to shift to the right. We know Lachette never reacts to a catalyst, and bubbling neon gas, an inert gas, is a trick also. If we dilute the solution, we change all the concentrations. So that's a fake answer. So if we look, decreasing the temperature. If heat's over here, we put a minus sign, and remember, take towards. A is your correct answer. That's an example of Lachette. Keep in mind, whichever side the arrow points to, that concentration always goes up. Whichever it leaves from, that concentration always declines, therefore increasing that ratio. This one, better conductor of electricity, means that you have more ions, greater number of ions. Remember, in solutions, subscripts matter. N2SO4 has 3 ions in there, or Van Hoff factor of 3. NaCl has 2 ions. So really you're looking for a correct explanation. They're both soluble because they have sodium. Molar mass doesn't play a role, fake answer. So then it comes down to either D or E. The correct answer is D because moles of ions. The number of ions matter. The fact that this has 3 ions means it's a better electrical conductivity. Dissociation is just how they break apart. Not the number that they break apart, but if they break apart. Since they both contain sodium, they both break apart, so E is not a correct answer. So the correct answer in this one is D. because when you talk about electrical conductivity, it is dependent on the moles of ions. Next one, this is graph reading. Solubility curve, greatest percentage of a compound that can be recovered, going from 90 to 30. Well, here's 90. Here's 30. Greatest recovery, remember, as you cool it, the solubility is going to decrease. So that whichever curve slopes the most will be the correct answer. If you look, the K103 curve has the greatest slope. So B is the correct answer for 39. 42. Remember, they give you the K for this reaction is 2.0 times 10 to the negative fifth. They want to know what the K would be if you reverse the reaction. Remember, when we reverse a reaction, we take the reciprocal. So that's going to be 1 over 2.0 times 10 to the fifth. Now, how are you going to do this without a calculator? If you remember, if you put numbers in scientific notation, so I'm going to change 1 to 1.0 times 10 to the 0, it makes it a lot easier to manipulate. First thing, 1 divided by 2 is going to be 0.5. And then numbers in scientific notation, when you go to divide, you subtract. So what's 0 minus 5 is going to be 10 to the negative fifth. But that isn't in correct scientific notation. So I need to bump the decimal over one place, making this 5.0 times 10 to the negative sixth. Your correct answer is B. Key thing is to remember that whenever you flip an equation, you don't change the sign. That's a fake answer in A. Don't fall for it. If you did, you need to correct that. It's the inverse. And then if it's the inverse or reciprocal, make sure that you put the numbers in scientific notation. It makes them a lot easier to deal with. Next one. They're telling you the atomic mass of copper is 63.55. There's two net isotopes, 63 and 65. So you get one at 63. You get one at 65. If they were 50-50, what would the average be? 64. But it's not 64, it's lower. It's closer to 63. So when you go to look at averages, this is reminding you that isotopes are averages. So it couldn't be 50. It couldn't be 25, because if it was 25%, actually the correct answer is 25% for copper 65. Because it's closer to 63, so 63 must be more abundant. So 65 has to be less, so it has to either be 25 or 10. Or if it was only 10% copper 65, the average would be closer to something like 63.1 or something like that, or 2 actually, 63.2. You just have to kind of look at it from a mathematical standpoint, that a isotope or atomic mass is an average. The closer the average, whatever number the average is closer to, means that one is more abundant. Mole fraction. How do we do mole fraction? 40%, 46% ethanol by mass, which means you have 46% ethanol, or 46 grams ethanol, which means you have 54 grams of agua fresca. So the molar mass of ethanol is 46. You automatically know from looking right there, 46 divided by 46 is going to be 1. The molar mass of water is 18. So if you notice 18, 54 into 18 is going to go 3 times. So I'm going to have a total of 4 moles on the bottom. They're asking me the mole fraction of ethanol. So if I put a 1 above, basically I'm going to put the 1, the part over the total. That's how I find mole fraction. The total is the 1 and the 3, the 4 on the bottom. The ethanol is 1, so I throw the 1 over it. It's going to be, your correct answer is going to be A. The mole fraction is going to be 0.25. Next one. Sodium chloride is least soluble. Well, what is sodium chloride? Sodium chloride is an ionic compound, which, remember, like dissolves like when we talk about solutions. So an ionic compound is going to be very solvent in a polar substance. It would be least soluble in something that is nonpolar, because that goes back to the old chemistry idea that like dissolves like. So if you look, we know water's polar. We know that's polar. That has hydrogen bonding, and that has hydrogen bonding. So both of those are polar. If you look at B, B is nonpolar. So if something is nonpolar, an ionic compound will not be, because the ions have charges, will not be very soluble. Next one, 50. Everybody got this wrong. Everybody picked B. Obviously, you can't put a hot object on balance. We don't use phenolphthalein. We only use a couple of drops. We don't use 10 milliliters. That's ridiculous. We don't do any diluting with hot water. So it's either B or C. We never, whenever you go to do a titration, rinse it the last time with distilled water because it would dilute the amount of solution we're using for titrating. So the last rinse in a titration is always with whatever the titrant is, if it's NaOH or whatever. So this one, adding a solid acid, which would be a weak acid, to a flask wet with water, if you make the solution, it's not going to change the molarity of the weak acid because the weak acid only dissolves or only disassociates by about 5%. It's kind of a bad question though. But keep in mind, this is the key thing you need to pay attention to. This is not true. We wouldn't use distilled water. We would use whatever we're titrating with. All right.